Good morning, everyone, and welcome to our Price Formation Enhancement Working Group Session number 9. My name is Brenda Corona. On behalf of the Stakeholder Affairs, we welcome you to the California ISO Working Group Session 9 for Price Formation. Today, we will be going over a few housekeeping reminders, as well go over the agenda and the process of where we're at. We thank you so much for joining, as this call is being recorded for informational and convenience purposes only. Engaged in perspectives. As well, we encourage comments to be both spoken through verbal and chat. So keep them professional and respectful communication throughout the working group. As well, we'll go into exactly what this working group session will entail. And then now we do have on the line from my event producer, Ahmed, and myself to ask and answer any questions, but we will be monitoring that as well. To ask a question, please use the raise hand icon located on your chat window. One second, my computer. So,
Brenda, I apologize. I think we are kind of having some intermittent audio issues in hearing you here in the session. I'm gonna do my best to channel you here. Oh, there you go. We can hear you. You're back. Go ahead.
Okay, yeah. I think my internet cut off for a second, but Ahmed, go ahead. Ahmed, can you go ahead and run the slides for me? It's not letting me. So.
Yeah, we'll go ahead and handle that. So, event producer, if you could take the verbal cue for the next slide. So again, just to kind of pick up here, you have the raise your hand icon, which is located in the lower toolbar. If you are dialed in only, then please press #2. Again, if you are unmuted, do not unmute. Wait, if we have a back and forth, which is that dialogue is something that we want here in these working groups. If you remute yourself, you will have to raise your hand in order to re-engage here. We will also have a Slido poll later in this session, and so you'll see that green Slido icon in the top right-hand corner of that slide. That will be populated in the lower right hand of your WebEx chat portion. So, Brenda, let's give you another. There we go. All right, loud and clear. Go ahead.
Great. Slide 4, we can go ahead and introduce the agenda for today. For today's agenda, we have today's goals, next session that Juan will take over for like a few minutes. He'll pass along and introduce a few folks who are here today. Guillermo and his team have provided initial analysis on fast start session.
Okay, Brenda, I apologize. It looks like we are losing your audio again, but I'm going to try to pick up right where you left off, which we have Guillermo Batista here to talk about that initial analysis on fast start pricing, and that is based off of the feedback we received on working group session number 6, and then we will be able to continue into an open discussion on the further refinement of that analysis. So if we could go ahead and move into the next slide, please. So again, we are here in this pre-proposal phase of the stakeholder process in the working groups. So this should be a slide that you're all familiar with, but again, just wanting to highlight where we are. Let's go ahead and move on to the next slide. We have a lot of really good analysis to present here. So the working group deliverable, one of the things that we had started off here was with the initial scope for this analysis. So again, this fast start pricing analysis will be taking on an iterative approach. We got your feedback in working group session 6. We're coming to you with this initial analysis. we're going to have multiple rounds. You're going to have an opportunity to comment on it here in this session, ask any clarifying questions, as well as provide any additional refinement that you would like to see for the next iteration, a subsequent fast start pricing analysis. So let's go ahead and move on into the next slide here. I just have a couple of them, and this is just to kind of recap again. What are the goals of today's working group session? I'm going to hand it off to our market analysis team here to go over, what they have come up with based off of working group session 6. So we're going to present that initial analysis, and then we're going to have an opportunity to have open discussion. You'll also have an opportunity to provide written comment on providing your feedback on fine-tuning that analysis. Again, this will be an iterative approach to it. So what can we do to continue on? Any good analysis, I think this has been said a couple of times, any good analysis will inevitably bring up more questions than it just initially what it was intended to answer. So that's what we're hoping to see, and we'll incorporate that into subsequent phases. So let's go ahead and get to the meat of today's session here. So if we could move on to the next slide, I'd like to just quickly introduce Guillermo Batusaldurete to lead us through. We're also joined by Quinn Zhao. So team, I'll hand the floor off to you. Please go ahead.
Can you hear okay?
We sure can, Guillermo.
Okay. Thank you for the introduction, and thank you to everybody for calling in for this session. Let me start with some background and context to what we are going to be discussing next for the 2+ hours. We came in October regarding the effort that we wanted to undertake for analyzing the potential implications of implementing fast start pricing in the CAISO market. We socialized a plan that we had composed of 2 stages, and we are back to bring you some update of what we have done so far along the lines of the original thought process that we have, but also taking into account the feedback that you receive. Now, as you will see through the presentation, there are a lot of items that are not specific to the analytics, are more related to the questions, open questions regarding how to design the fast start pricing. And they are put in there mainly because in order to analyze one way or the other the implications of fast start pricing, we have to come with an approach. We have to implement and analyze one type of fast start pricing. So all these questions you are going to see through the presentation about the definition, the timing, the approach, the other, the type of resources, the eligibility, all this has to do with, at the end of the day, we want to do some assessment, and we have to come at the end of the day with one specific calculation. That's the main reason you are going to see many of these coming more like policy-related questions, not because we are doing policy on the fly, but because, again, they are inputs to eventually what we want to analyze and what type of variation of fast start pricing we may want to explore in this analysis. And that's the reason you are going to see that type of context in the discussion. With that, let me start going through. I have Quinn from one of our teams also participating in the discussion, and we will be interchanging the presentation. So if we can move to the next slide, please. Process-wise, plan-wise, we indicated that we want to take an incremental approach. We came in October indicating what was the plan composed of 2 stages. The first one is what we're presenting today. It's a preliminary set of analysis we have done along the main features of fast start pricing. There are some salient features that we want to highlight in terms of how we have approached this analysis. We have taken into account the feedback provided by participants in the previous round. And this is for the sake of setting the stage of what the final analysis is going to be. We're expecting that once we complete this discussion today, we receive your feedback. We're going to come back to the whiteboard and come with a final approach for the analysis. Some of that is going to be predicated on the same basis that we already use and expanded in different directions, or potentially changing some features of what we have implemented in the analysis. So that in the second phase, we can have this final analysis that we can discuss. And ideally, we're expecting to target this for somewhere in March, most likely in the first half of March 2024. And again, the purpose of this is to provide some analytics of what it could mean to have fast start pricing in the CAISO markets. And when I refer to CAISO markets, I do it loosely because I really mean the entire footprint, including the Western Energy Imbalance Market when it comes to the real time. Next slide, please. What do we have right now for this first preliminary stage of the analysis? This lists basically the components that we have addressed in this first stage of the analysis. And we'll start with some basic statistics of the generation fleet. Many of the defining questions we have to answer potentially regarding fast start pricing has to do with what type of technology, what type of resources make up our generation mix. Because depending on that, that is going to largely influence how we are going to set up the definitions for fast start pricing if we move forward in that direction. The second part accounts for some trends of bit cost recovery. Bit cost recovery is closely attached to the implications of fast start pricing because a consequence, a collateral implication of fast start pricing is that it's going to raise prices and it's going to reduce to some extent the bit cost recovery. So it's important to have in context how our bit cost recovery has been played for the recent time. Then we go into the nuances of what we have implemented so far in the analysis. For the scope of this first stage, we basically proved the concept using only the CAISO balancing area applicable to the real-time market. And even though it's showing results only for the CAISO balancing area, it is structured in such a way that it already accounts for the dynamics of the Western Energy Imbalance Market. We are accounting the effect of the wind market in the CAISO balancing area, and that means that now we can naturally expand that analysis to all the balancing areas that are participating currently in the wind market. And we do that by accounting effectively by the economical transfers that are happening in the real-time market. Remember, the fast start pricing is about prices. We already know the optimal solution that we get from the real-time. That is our starting point. So we account for the economical displacement of internal supply one way or the other when we reflect the effect of the transfers. In the last round, we also discussed the potential implications of flexible ramping products. So we have found a way to incorporate the flexible ramping product in this analysis, and effectively it's just the reflection of the economical displacement of the capacity associated with the procurement of flexible ramping product to set the prices. And then we go into 4 different scenarios. There are 2 dimensions to the scenarios that we're going to present. One dimension is regarding how we calculate the adder for incorporating fast start pricing. There are 2 variations. One is a constant adder, just a flat value across the variable range. And the second one is actually a suggestion proposed by Michael, that is with us today, regarding a more sophisticated approach that relies on the minimum average cost to determine what the adder should be. The second dimension to this is the configuration of the fast start definition. Whether the definition should be based on 15-minute fast start units, 30 minutes, 60 minutes, that is still quite an open-end question. And just to give some sense of the direction of the implications of using one definition versus the other, we have 2 scenarios. We assess what happens if we consider resources under 30 minutes for fast start or under 60 minutes. And again, there may be other dimensions how we can play these conditions. And the definition that we use here have to do with meeting both the startup times and the minimum uptime concurrently. It has to be less than 30 minutes together or less than 60 minutes together. The other piece that we explored, or at least discussed lightly in the previous run, was regarding the expansion of this fast start pricing to a unique feature that we have here in the California market. And that has to do with how we model combined cycle units. We use this very sophisticated model that is the multi-stage generator model that relies on states in configurations. And when we have this commitment decision to move from one current configuration to another configuration, you could extrapolate the thought process as well. This is kind of equivalent to a startup decision because it involves these discrete conditions. There is a transition cost, there is a transition time, and there is a commitment cost involved with that transition. So for this first phase, we have actually expanded the model to incorporate the multi-stage generator units, and we have material to go into the details of how we do that. And the last piece that is very specific to the CAISO area, and specifically to the day-ahead market, is the constraint that we implemented. That constraint may be as old as 2010, 2011. And per operating procedures, there is a requirement in certain local areas to guarantee that there is a minimum online capacity in that area. We have achieved this through the inclusion of a constraint that we call the minimum online constraint, the MOC. And this constraint is to ensure that there is a minimum capacity online. That is going to influence for sure the commitment decisions made by the market. These are not manual dispatches. We are not forcing specifically a unit to be online. We impose this constraint, and through that constraint in the market clearing process, the market finds the best way to meet that constraint. The complexity is that that constraint is a discrete type constraint because it's based on commitments, and therefore there is no price signal generated with that constraint that is incorporated in the market clearing prices. The implication for fast start pricing is that when these resources that belong to an MOC are committed, are started up, it's not because pure economics, it's because of this constraint. So there is a item to consider whether this type of resources should be able to set the prices, and therefore whether they should be able to have the fast start pricing logic incorporated as well. Now, this is a more meaningful discussion when we are talking about the day-ahead market, because this constraint is actually enforced in the day-ahead market and not in the real time. If there are commitments made in the day-ahead market, and these are for long start units that by default are not within the definition of fast start pricing, they are going to be binding in the real time and they have to be online. But for those that are fast start by definition, they are not going to have any binding commitments going into the real time. So whether they are MOC or not is irrelevant to the discussion of the real time, because by definition, if they are fast start, it is until the real time market that is going to be defining whether these units are going to start or not. So it's a more relevant discussion for the day ahead construct rather than the real time construct. Still, we track those, and if there is any unit that is driven by the MOC, they may not be able to be setting the price through the fast start pricing as this to this analytics that we are doing. This is really what composes the preliminary analysis that we have. As you may notice, we have put a lot of effort in this first phase to try to make as detailed as possible the foundational aspect of the market clearing process. It is critical to have these key components that influence the market clearing process to ensure that we can expand on this foundational model. And once we have that in place, we can easily expand that to the balancing areas of the EIM market or potentially include other type of sensitivity scenarios that we may consider if the 30 minutes, the 60 minutes is not sufficient to get that picture of the implications of implementing fast start pricing. Okay, let's move to the next slide, please. And here comes the decision point of how we can model the fast start pricing. Again, these are kind of design-related questions, but they are needed because in the end we want to analyze something. It has to boil down to a specific decision point on this. And one of those is whether this fast start pricing should be day ahead and real time or only real time. I think the majority of the ISOs in the East rely on both day ahead and real time. There may be one ISO that only uses this for the real time. That is still an open question. Right now, we have analyzed this in the context of the real-time market, because when we move to expanding this to the Western energy imbalance market, we only have meaningful information in the real time for these EIM areas. The second dimension of decision regarding the fast start pricing has to do with the time definition. What resources should be considered for fast start pricing? Should those be only with 15 minutes, 10 minutes, 30 minutes, 60 minutes? Anything else or any permutation of that is subject to discussion. Again, for this analysis, we have just going the simple way, taking two cases, the 30 minutes and the 60 minutes. There is another inherent component here that has to do with the time definition, and that has to do with the attributes of the resources. Some resources may be naturally eligible to be fast start pricing if they are just with few minutes startup times. That could easily be considered that by default they should be considered for fast start pricing. There may be other resources like depending on the type of participation that indeed even though they may have all the attributes to be considered fast start pricing, they shouldn't be able to set the price. And one of those is the classical definition that they are price takers. They are self-schedulers. Even if they are with the attributes, they shouldn't be considered for fast start pricing. And the other dimension to this is the type of amortization. Once we have to move into fast start pricing, it is a matter of how we are going to incorporate the commitment cost into the variable bids. Specifically, how to incorporate the startup cost, the minimum load cost, the transition cost. And in that sense, there is a key component to define how the amortization and for how long the amortization should apply to the resources that are going to be deemed applicable for fast start pricing. Next slide, please. Now, going into the generation fleet, when we refer to the CAISO market, again, we refer to the overall Western energy imbalance market. We have some definitions by technology. There are some resources such as PDRs, storage, solar, and wind that basically have zero or very small startup times. So by technology, we could consider that they are going to be by default subject to fast start pricing. Now, many of those may also have zero commitment cost. In that case, it's kind of a moot point because even though they have these attributes, there is nothing to amortize just because there is no commitment cost. And there are imports that potentially could be considered to setting the price. In the real time, given the fact that we are using the 15-minute market for analysis, the imports are there as fixed capacity because they have been cleared in the HASP process. Therefore, they are not able to set the price even under the current standard pricing in the 15-minute market. For the few exceptions of those that are 15-minute resources, that maybe one or two lingering there. But the majority of the transactions are hourly intertied. So in the day ahead, that would be a relevant point for discussion. Multi-stage generators, they may have some similar characteristics to single startup units, and there is a lot to consider how to incorporate those for multi-stage generators when we are dealing with specifically configurations or change of states. And naturally, I think the main focus is going to be on gas-fired plants. There is a spectrum of attributes in that classification, and some of them may fall into this fast start pricing definition. On the other hand, we have the type of participation. Not only having the attributes is important, but also what type of participation they have. They may have fast start characteristics, but if they have no commitment cost, there is really nothing to amortize. Those that may still have fast start characteristics, but are self-scheduling in the market, they will not be able to set the price even under the current structure. So there is no expectation that they should be subject to fast start pricing. Then the resources that we have as part of the MOC constraints. In the context of the day-ahead market, that is something that we have to consider. For the real-time market, that is not a relevant item for discussion. And again, there are many resources that even though they may have the attributes, at the end of the day, may have zero commitment cost that makes them just a moot point for consideration in the fast start logic. Next slide, please. When it comes to the time definition, there are two critical times here. One is the startup time, how long it takes the unit to bring and be stable at the P-min point. That is the startup time. We also have the minimum uptime, that is the time that is required for the unit to stay online, regardless, because that is a temporal constraint. And this is typically one of the key drivers for which some units may incur bit cost recovery, because in order to comply with the minimum uptime, they have to be dispatched at least at P-min, and in some cases, the prices may not be able to support that dispatch. And when we move to the multi-station generator units, the transition time is equivalent to the startup time. So given these three times, the critical question is, what is the threshold to consider whether a unit should be in the group of fast start units or not? Whether that should be any time threshold is subject to this policy discussion that potentially may come later. Whether it's going to be 10 minutes, 30 minutes, 60 minutes is a point for a key component in the design. And in the scenario that we have analyzed, we consider again two conditions: those that are 30 minutes or faster, or 60 minutes or faster. And again, these thresholds are applied concurrently to both startup time and minimum uptime, or transition time and minimum uptime. That means in the analysis that we consider for units under 30 minutes, it has to be a faster, startup times faster than 30 minutes, concurrent with minimum uptime of 30 minutes or less. It has to be both characteristics in place. And again, that is still a point of debate whether that should be the right definition or something else. Next slide, please. Okay, let me pause here before we go into the actual numbers that we have to see if we have any questions regarding the setup and the context of the definitions, the concepts that we are using for the analysis that we're going to present next. Juan, can we check if we have any comments, questions so far?
Absolutely. So we do not have any questions in the chat for right now, but before we move on, please go ahead and raise your hand or hit #2 if you have any questions for Guillermo before we continue on here. So Guillermo, looks like none on the audio line, and I am not seeing any slides as well. So everybody, please feel free to raise your hand as we move forward, but Guillermo, you're free to continue. Thank you.
Thank you, Juan. Let me pass it over to Quinn. She's going to introduce two sets of metrics about the generation characteristics and the bit cost recovery.
Thank you, Guillermo. So hello, everyone. This is Quinn from Market Analysis. In this part, we'll be looking at some fundamental statistics to set the stage for the fast start pricing impact analysis. Specifically, we'll be exploring the resource characteristics of the WEIM generation fleet in relation to fast start pricing. We'll then analyze the historical bid cost recovery payments within the overall WEIM market, focusing on attributes applied to FSP. So now let's jump into our first slide. This slide, we've grouped the total capacity of the entire WEIM generation fleet, that is, all the participating resources by min-min uptime groups and startup time groups presented side by side here. As of December 1st, we're looking at a total capacity of over 190,000 megawatts from CAISO and WEIM participating resources. As you can see here, approximately 60% of this capacity falls into the 0 to 30 minutes startup time category. And looking at min-min uptime, about 46% of the share is held by resources with 30 minutes or less of min-min uptime. And that is potentially the share that could meet various fast start pricing definitions. Next slide, please. An alternative perspective on the generation fleet is to visualize capacity across different technologies. Each bar here represents one type of technology, and within each bar, we have a stack of 3 startup time categories. And fast start units, that's those with less than 30 minutes startup times, are composed of solar, wind, water, storage, gas, and this other type. This other type here includes types like hybrid resources, demand response, DRs, and types of bio, etc. Next slide, please. Similar to the grouping of the previous slide, this metric provides a breakdown by technology, and within each bar, we have a stack of 3 min-min uptime categories. And units with short min-min uptime, like 30 minutes or less, are concentrated within the similar technologies as the previous slide, such as solar, again, wind, water, storage, and the other type. And notice that the majority of the gas units have 30 minutes or more min-min uptimes here. And it's worth noting that while some resource types like solar meet the fast start pricing definition, their impact may be limited due to the associated $0 commitment cost. Next slide, please. Okay, before I change topic, any questions on the generation fleet?
So we do have one question in the chat here, Quinn. Is the fast start pricing embedded in the day ahead price, or is it added to the clearing price? Would you like to take that one now, or would you like to circle back to that one?
So our analysis or current expectation is more concentrated on real time, and it's pricing run only, so it's price setting procedure, not scheduling. So scheduling run will set the schedules and then megawatts commitment, and pricing run will set the price, and fast start pricing will be applied in the pricing run only.
Let me add on that, Quinn. I may get a sense of what the question is about. If I understand the question, is whether the fast start pricing implies that we are constructing prices with incorporation of the commitment, or whether we generate the standard prices and then we add some type of other. So it is the price formation. So fast start pricing goes to change the price formation in the market clearing process that incorporates the commitment cost. Is not the approach where we generate the standard price and then we put on top of that another. It really changed the whole price formation structure.
Thank you, Guillermo, for that.
Okay, I think that had a couple of hands go up here. So why don't we, event producer, if we could start with Dina, and then Mark, I see you as well. We'll go to you. So let's unmute Dina here.
Mackin, you are unmuted.
Hi, thanks. And I'm sorry, I'm new to this this process, so I'm just getting up to speed. But what I don't understand is if it's embedded in the actual price and the price is set by all of the generators putting out their marginal cost, and the clearing price is market determined. Why is it that we need to create a price formation mechanism that is additional to what they are already bidding? Because wouldn't they be embedding their own costs into the bid anyway?
Yes, I can take on that. Yeah, I appreciate your question, and your question really goes to the core of the principles of fast start pricing and the merits to have fast start pricing. You are right. Participants are required to submit three-part component bids. They have to submit bids for the variable range that defines the marginal cost for operating the resources anywhere between the PMIN and the PMAX. They also are required to submit costs for representing their startup cost, the cost that is incurred for bringing the unit online. And there is also the requirement for them to submit a minimum load cost. That is the cost that the plant has to incur for having the unit operating and synchronized and be online, regardless of what operating level is at. Now, you are right that when we go into the standard pricing, the variable bid that represents the marginal production cost in that variable range is going to set the price. That is the current standard pricing mechanism that we have. The complication is that by the way we have a market clear, and that is not specific to CAISO, it's for any market clearing process in the centralized unit community market that we have in any of the ISOs. There is a very well-known consequence of having a least cost dispatch, and that is that the market is going to optimize based on all these components, but the resulting prices that are going to be set by basically the variable range, in some cases may not reflect or may not be high enough to cover all the cost incurred by running the plant. Specifically, may be short to cover the cost of starting up the unit or operating the minimum point of the unit. These are the costs that in some cases may be not recovered through the clearing prices, the LMPs. And that has been one of the genesis discussions in the past when it comes to faster pricing. How can we ensure that the clearing prices may reflect to some extent this commitment cost so that the resulting clearing prices may be able to cover those discrete lumpy costs that are not reflected in the variable bid. I appreciate your question. I want to make sure that we don't go into the debate of why to have faster pricing. I think we are open to that discussion. The way we have structured this discussion is that we want to provide insights of what would be the implications of potentially implementing faster pricing, and that is going to open up the whole area for discussion about the pros and cons and the merits for potentially exploring faster pricing. I hope that my answer suffices your question for now, and we will discuss more details on the implications of faster pricing as we progress in the presentation.
Yeah, I think that helps. Thank you.
Okay, let's go ahead and go to Mark. And I do see we have a couple in the chat as well. Let's go to Mark first for the verbal question, and then we will get to the question coming in.
It's Mark Smith with Calpine. Can you hear me?
We sure can, Mark. Please go ahead.
Thanks, Juan. Thanks, Quinn. And first of all, happy holidays to everybody. The last two slides that you have shown here bucket the generation fleet in separately startup and minimum run buckets. Have you analyzed the combination of those two to see how the fleet looks for adding both start and min run times as it's been proposed?
Yes, we have a different breakdown, but we didn't put it in here. We can definitely show that result sometime in the future.
Okay, I think that would be helpful if indeed that's a consideration in designing the eligibility. Thank you.
Yeah, thanks for the comment.
Okay. So no more hands up, but we did get a couple questions here in the chat. I'll go ahead and read them out loud to you, Guillermo and Quinn. So generally, we don't expect IFM to have BCR since it already has a 24-hour horizon. Is the IFM BCR driven by minimum online capacity constraint, or are there other reasons?
Yes, I can take on that. So I think this question may have different components to answer. The first one is that it is right that in the day-ahead market, specifically to the integrated forward market, that is the financial market where we make the decisions for commitments and dispatches, we run this holistically for 24 hours. We do not optimize hour by hour. We optimize across the horizon of the 24 hours. I have to say that in spite of that full horizon consideration, there will be conditions in which units are going to be dispatched uneconomically. And even if it is 24 hours, even if it is day-ahead market, the potential exists for that to happen. And a very classical example that we have used in the past is that there may be cases where you have these units that require long startup times, long minimum up times, and you need them badly to meet the evening ramp and peaks. And the only way you can gain access to that capacity is by committing the units early enough to be able to move them through the range and be available for the evening. But it happens that prior to that critical time, we have plenty of solar production, our prices are going to be relatively low. These are the perfect conditions in which in the middle of the day, they have to be online just to be ready for the evening ramp and peak. And therefore, they are going to incur losses in the middle of the day when we have low or even negative prices. So the day ahead doesn't guarantee that BCR is not going to exist. There will be conditions where it happens. Now, that is in principle. Beyond that, there are practical conditions that may induce more bit cost recovery, and one of them, rightfully as stated, could be that we have other conditions leading resources to be committed beyond economics, and one of them, as I indicated earlier, is this minimum online capacity constraint that is forcing resources to be online for the specific conditions for the specific areas, and that is going to exacerbate potential levels of bit cost recovery. Thank you.
Thanks, Guillermo. I saw Ian's hand jump up here. Let's go ahead and unmute Ian, please.
Slide 16. It's a rather dumb question in my typical style. On the labeling, you have the in the different colors on slide 16. Minimum up times, and there you have 0, 30 and 60, or 30, 60. Are we talking about minimum run times here? Or are we talking about startup times? It wasn't clear to me from the context. I'm thinking we're talking about minimum run.
Yeah, this one in the subject line we have minimum up times there. So this one is a breakdown of the minimum up times, and the previous one was about minimum startup times.
Okay, all right, that's helpful. Thank you.
Thanks for the clarification. Yeah.
Okay, we have one more in the chat here. So currently, commitment costs are mitigated separately from marginal energy bids using commitment cost caps. With fast start pricing, how will commitment costs be mitigated?
That's a great question for discussing the policy. I don't expect we're going to iron out this through the analysis. And that is the reason I caveat at the beginning of the presentation, right? We have to make some assumptions of potentially what approach we take for faster pricing in order to be able to implement that analysis. But there are many salient features that have to be discussed, and one of those is as pointed in this question. So I would leave it open for subsequent discussions on faster pricing.
Thanks for that, Guillermo. Yes. One last question here before we move on, unless others come in. The question is centered around May of 2023. What happened after May of 2023 to drive up the RUC BCR? With the changes in MOC, load biasing, do we have any idea there on what happened after May of 23?
I can take on that, and I will make an advertisement. We have a whole dedicated section that we're going to cover in the upcoming Market Performance Forum meeting 2 days from now on Thursday. So I would encourage people to participate in that discussion. This is one of the topics. I can give you the spoiler here. And the reason you see bid cost recovery increase dramatically for the last 4 months or after May is because we effectively changed the logic, the calculation to estimate the RUC adjustments. There is a lot of information that I'm going to fail to summarize concisely in 2 minutes when we have potentially 20 slides to go in detail. That is what I can tell you quickly without diverting our discussion here. It was because we changed practice of the RUC adjustments we use in the day-ahead market. For more details, please, I encourage you to participate in the MPPF on Thursday. Thank you.
Thanks, Guillermo. And yes, the Market Performance and Planning Forum will be, as Guillermo mentioned, Thursday from 11 a.m. to 4 p.m. So I do encourage you to join if you're interested in that topic. So no further questions, Quinn. We can go ahead and continue on with the slides. Thank you very much, everyone.
Thank you. Thank you, Juan and Guillermo. So let's move one slide forward. We have some BCR questions already, but let me just start fresh. Shifting gears, we'll delve into this bid cost recovery topic. It's a mechanism designed to make whole units that are uneconomically dispatched in the market. And this metric includes the BCR for all units in the WEIM area. On this slide, we have a snapshot of the monthly total bid cost recovery payments spanning from January 2021 to November 2023. And due to the settlement data availability when this metric was generated, November this year includes up to November 27th, and more recent days are still based on preliminary data subject to changes. Over this reported period, the average monthly BCR payment is about $21 million. We observed a peak monthly payment exceeding $60 million in December 2022, attributed to the high gas price conditions. And the set of BCR slides will break down the total BCR payments from different perspectives. And on this slide, each bar provides a distribution of the breakdown of the monthly BCR payments across different markets. We see the RUC and then real-time payments make up the majority part of the total payments, while relatively smaller contributions come from IFM. Next slide, please. And this slide shows the BCR breakdown by region, how BCR impacts different areas within our market. And let me clarify this first. The region definition here is for data visualization purposes only, not a market-defined term. For example, California here includes already LADWP, Bank, TID, and CAISO. The primary share of BCR concentrated in the California region and more specifically from CAISO areas. Next slide, please. This slide presents the BCR breakdown by technology type. As we see here, the vast majority of payments are accrued on gas units. There are some allocations to water and storage, and that's not likely commitment cost related. This suggests that the gas units may be the most relevant technology type for the fast start pricing feature, and unsurprisingly. Next slide, please. Moving to next slide, we'll break down the BCR payments based on startup time categories. There is a relatively even distribution of BCR payments across the startup time categories. See here with comparable magnitudes observed for units with less than 30 minutes startup time and units with more than 1 hour startup time. Next slide, please. We then break down BCR payments based on min and uptime categories. It makes sense that the largest share of BCR payments goes to units with more than 1 hour minimum uptime. That's a category in blue. Units with longer minimum uptimes are more likely to remain operational due to minimum uptime constraints rather than pure economic decisions. Next slide, please. Okay, this is the last slide of the section. This last slide shows the CAISO BCR breakdown by minimum online constraint, the MOC we talked about. MOC derived from operating procedures may require a minimum quantity of committed online resources to ensure reliability. And MOC is enforcing day-ahead only, so only applicable to CAISO areas for now. Units associated with any MOC constraints presents a relatively small share of the total CAISO BCR. That's the pink color at the bottom of the bar charts. So summing it up, we've explored how BCR is distributed from various angles. This provides a holistic reference on the various key factors to consider for the design for fast start pricing. So that's the end of this section. Any questions before I hand it back to Guillermo?
All right, Quinn, I am not seeing any questions in the chat here. Do we have, nor hands, do we have any on the audio line, event producer?
There are no questions on the audio line.
Okay, thank you, Ahmed. Guillermo, please feel free to continue. Thank you.
Thank you, Juan. Thank you, Quinn. Can we move to the next slide, please? Well, now let's go into the actual analysis we have done for incorporating cost to the different variations of fast start pricing. And for fast start pricing, let me put it together. What are the salient features that we have to consider in this analysis? First, in some fashion, we have to incorporate the cognizant cost into the variable bits. As indicated, we have two approaches, a constant adder and also an average, minimum average cost adder. Naturally, what is going to happen is that by the fact of incorporating this cognizant cost, we're going to end up with higher bits. And higher bits is going to mean that we're going to clear up higher prices because now we're trying to incorporate this cognizant cost. These higher prices are going to have the byproduct consequence of providing additional revenues to resources and therefore are going to reduce to some extent the bit cost recovery because now units are going to be dispatched uneconomically to a lesser extent. The way the faster pricing is implemented in principle is kind of standard. And that is, regardless of the nuances of the actual price formation, there is this construct of the ISO market in which we rely on the standard construct of having a scheduling run and a pricing run. And we have had that structure since day one of the nodal market. In the scheduling run, the focus is to identify, to determine the optimal commitments, what units need to start up, shut down, transition up or down, and come with the specific dispatches for the resources. These are based on the scaling run that utilizes all these scaling parameters that we use to enforce the different priorities that we have in the market. And different schedules are going to have different priorities based on the specific guidelines of the tariff. For instance, something that has been very well discussed in the recent past in the context of the scaling parameters has to do with the priorities for exports. And the higher the priority, the higher the scaling parameter, and numerically, that is going to help the optimization to determine the sequence, the right sequence of scheduling resources when tight conditions exist in some fashion. Once we have determined these optimal schedules, internal to the optimization, we move into the second pass that we call the pricing run. This is the price that starts from the results of the scheduling run and comes with this price formation using what we call the clean setup, because we no longer have these high scaling parameters in the range of few $1,000s. Now, all the scaling parameters are basically collapsed to the bid cap or to the bid floor, and that is what we have called the economically meaningful prices. We are somehow cleaning up the prices out of these scaling parameters that are used to set the priorities. And therefore, when we come with these clean prices in the pricing run, we have the binding prices. And these are the economical signals that we send through the market. A few years ago, specific to the CAISO market, we actually changed a little bit that construct. We continue to have a scheduling run and also a pricing run, one after the other. But since that implementation, we have actually used both the schedules and the prices from the pricing run. Now, this is relevant to the discussion and eventually could be more relevant for the implementation, because when we go into the fast start pricing mode, the whole logic applies in the pricing run. We are done with the schedules. We have to figure out now these new prices incorporating the commitment cost. So there will be some work to be done, how to reconcile the current structure that we have, potentially what changes we may have to implement to align with the fast start pricing, because now the fast start pricing may not only generate prices, but also schedules under the current construct. If we were to be relying on the schedules also from the pricing run with the fast start pricing, effectively we are going to be transpiring imbalances into the actual operation of the system, because one of the approximations that are used in the fast start pricing is that we allowed or we model these startups to be flexible, and therefore they can be dispatched anywhere between 0 and the PMIN only for pricing purposes. But again, given the fact that now we have schedules also used from the pricing run, we have to do some synchronization with these two logics. And that is something that potentially could be down the road, way down the road, once we have decided whether there are merits to move forward with the fast start pricing. Next slide, please. Well, now let's go into the specifics of the basics. We have these two approaches, constant and average amortization. And these are the two scenarios we are presenting today. The other key component is the period for which the amortization should apply. And here, actually, there are two elements. One is obviously the definition. if a resort has a minimum uptime or a startup time less than a threshold. That would be one concept. But there is a nuanced consideration here that could go either way. And that has to do with for how long we consider the commitment cost when the unit is up and running. At least we have to consider that the minimum load cost has to be internalized for the period the unit is meeting its minimum uptime. But what about times when the unit has already exceeded its minimum uptime and is just running because it's still needed? If it is still up and running, it's still incurring minimum load cost. So there is this subtle consideration whether the minimum load cost should continue to be amortized beyond the minimum uptime because it's still online and it's still incurring in that minimum load cost. For the approach that we analyzed so far, we took the more surgical consideration, that is, we only consider amortization of the minimum load cost for the period where the unit is meeting its minimum uptime. But again, it's a decision that has to be defined in the policy discussion. Next slide, please. Okay, let's go first with the first approximation of the fast start pricing, and this is the easy one. The key question is, how do we incorporate the commitment cost into the variable bits? And this one takes a very simplistic approach. We have the market bit. In this case, let me just illustrate with some approximation. We don't have a slope-wise bit segment bit in the market. We use step-wise, and even more basic. But for simplicity, let's just say that we have the market bits as is. Now we have to estimate how much we have to internalize in that bit the commitment cost. Commitment cost for the startups is specific to the startup cost and to the minimum load cost. Minimum load cost is MLC, the startup cost is STUC. And for the minimum load cost, it's already per hour. So it's a matter of just amortizing that cost, getting an average cost, and dividing that by the Pmax. So we're assuming that if we operate the unit at the maximum level of the variable range, we're going to amortize that minimum load cost in that Pmax range. It's a simple average cost, what we are doing for the minimum load cost. It's the same logic that we apply to the startup cost. The only caveat here is that the startup cost is per event, per startup. It's not per hour. So we have to basically translate or convert that to be basically energy, similar to the minimum load cost. So if the startup time is, the minimum uptime is, let's say, 30 minutes, well, that the startup cost has to be amortized over these 30 minutes. It's producing energy only for the first 30 minutes. And the logic that you have there for the startup cost, the component that is in the lower part, is only to translate that minimum uptime to how many intervals in the market we have to amortize the startup cost. So let's say the minimum startup time is 30 minutes. That would be 30 minutes equivalent to 2 market FMM intervals. So we're going to basically amortize the cost in 2 intervals. If there are units that have a minimum startup time of 0, effectively we use this max of 1 or the rest. So we have to amortize the cost at least in 1 interval. And that is the reason we have this max conditional there. And again, we have to divide that, assuming the unit is going to operate at the Pmax, like we are going to amortize the cost over the full range at the Pmax. All these minimum load cost, startup cost, Pmax, and minimum uptime, all these are parameters. These are given values. They do not change with where the unit is operating. And therefore, the other gamma in this case is going to be a flat value, just a number. It's a constant value based on constant parameters. And what you have here in the second plot in the center is just a physical illustration of that other, that is just a flat value across the full range of operation of the unit. So when you have the market bit and you add this constant other, The only thing we are doing is just shifting up that market bid by the amount of the ad. If we move to the next slide, please. Operator, can we move to the next slide? Okay. This is how it looks in practical terms for a real bid in our market. You have the range of the bid from Pmin to Pmax. Pmax is 450 megawatts, Pmin is 100 megawatts. It's a monotonically non-decreasing bid, a stepwise bid, like what we allowed in the market to be. And it has a price for each of these stepwise segments, going from beta 1 all the way up to beta I. And that is depicted with the trend in turquoise or blue. Now, if we assume we have minimum load cost of $5,000 per hour, a startup cost of $2,000 per start, we have a simple minimum uptime of 1 hour, and the Pmax is 450. We can easily derive this other, the gamma sub E. That would be the total cost, the commitment cost of 7,000 divided by the Pmax of 450. So we derive an adder that is about $50.5 per megawatt hour. That is the adder that is going to be put on top of each of the bid segments that we have in the market. So it's going to shift up by the same amount for every stepwise segment of the bid. That is the first step. Now, the second step has to do with the formulation indeed of fast start pricing that implies that we can model the resource to be flexible, in the sense that under the current framework, we don't allow dispatches to happen anywhere between 0 and Pmin. The unit is not online, it's not synchronized, cannot deliver a stable output anywhere below the Pmin. For pricing purposes only, we assume that the unit can be indeed dispatched anywhere between 0 all the way to Pmax. And what is typically done is to expand the first segment of the variable bid all the way to 0. And that is what you have here as beta 1 sub m. That is just the expansion of the first segment that was between 100 and 150 megawatts all the way to cover now the 0. With that, we are really covering the Pmin range, and we are going to allow the price and run to dispatch this resource even in that range. And I see one hand, Juan. I think
yes.
Michael,
no, thank you. That's Michael Cobblewater. So, Michael, please go ahead.
Thanks. You can call me Mike, by the way. I just want to make sure I'm understanding the example fully. So, the $5,000 MLC, I'm assuming that's essentially the 100 megawatts at Pmin times, it looks like the $50 cost that is sort of on the, well, yeah. Where is the $50 coming from?
The 5,000 is the minimum load cost.
Right, but how's that calculated?
This is basically the cost submitted by the participant, right? They can submit, and we put some caps to that value. It's a value that they can submit up to some headroom that we give them.
But that's the cost to operate at 100 megawatts.
Correct, at the Pmin.
Okay. So we're adding that to the 2,000. So we have $5,000 to operate at 100 at Pmin. So $2,000 for the startup cost. So a total of $7,000 in commitment costs. We're allocating that over the 450. I see the entire 450 megawatts of the unit, which is getting us to 1555 per megawatt hour.
Correct.
Okay, I'm just trying to make sure in my head here that the math works out. because we extend the bid for the first segment, the segment that's just in excess of 100 megawatts and doesn't above PMIN, and we're adding 1555 to that. If we extend that all the way over to the left, and we're still adding 1555 to it, we hadn't included any positive incremental energy cost associated with that 0 to 100 segment. If we're going 1555 above that, aren't we double counting? I'm just trying to make sure I understand the math here.
Yeah, and I think, Mike, you're going into precisely the type of discussion that needs to happen, right? Precisely how we can determine these others. I believe in the previous round, we came with a slightly different approach. For instance, just discounting the cost that you already recovered in the first segment, right? And it was, I don't remember the formula, but it was more like MLC minus the first bit segment times the segment of that of the PMIN, and then divided by the PMAX. That gives you a more conservative approach because now you are discounting the cost that is already associated to be at PMIN. That is the first formula that we introduced in the previous round. And again, this could be different ways of how we come with another. I think the point here is how can we come with something simpler that is just going to be a constant other rather than going through the more sophisticated logic that you propose.
I understand. I'm just trying to make sure that the constant adder doesn't actually change the cost of the unit. I guess I need to do a little bit of math on my own. Okay, thank you.
Sure.
Thanks for that, Mike. And I like the single syllable, so I'm going to call you Mike from here on out. I see we also have JK. JK Wong with her hand up. JK, please go ahead.
JK from PGE. Thank you very much, Guillermo, for walking us through the assumptions here. I have a very basic questions, but my apology if you mentioned that before. So the example we presented here is a bit curve. I somehow remember that when we say the fast start pricing that it will be block loaded unit. So I'm a little confused here when we see a curve that actually rising up. Can you help me to understand if that's still an assumption that we'll be looking at block loaded units or that's much more relaxed here?
Yeah, yeah, that's a great question, JK. And this goes again about the spectrum of possibility, right? How far we go into the fast start pricing. I can tell you that as of now, indeed, the market has already some logic to consider how we call, it's called COG units. Effectively, those units that have basically no variable range to operate. The PMIN is pretty close to the PMAX. We already have some type of fast start pricing for these units. And for the last 10 years or so, I don't think we have seen a unit using that model. So, and your question really goes into the definition of what we should consider. Again, for this type of analysis, we have to ground on something, right? We are not saying that this should be the way to go. At the end of the day, we have to come with some method, some logic to assess that somehow is within the spectrum of possibilities. The number of scenarios or permutations we can consider could be endless, so we have to be mindful which ones could be more meaningful. And if at the end of this discussion, there is evidence that, well, maybe there is another scenario that makes more sense to explore, we are happy to switch to use that other approximation.
Okay, that's super helpful. I think it's also, I think it just helped to clarify our basic assumptions from the beginning, because what I thought, and I think probably many of us thought from the description of the web page, is to allow the fast start unit to set a price, which is not allowed now. So that somehow implied it will be block loaded units. But what you just said seems to indicate we're also looking at a more extended range of units that potentially may already be able to set price now, but not including their unit cost in unit commitment cost in the price. Is that right way to put it?
Let me put it in my own terms again. And I would say that we are not married to one specific approach right now. We have to come with something to be able to do some analysis, right? But your question is really more about the decision points that has to happen through the policy of how far, how wide open should the consideration of fast start unit and modeling be. And I believe that is still a discussion to happen.
Right. My apologies that I'm trying to make you answer a question that doesn't seem belongs to the scope, because the only reason I'm asking is if it is not limited to the block loaded unit and we're looking at a big curve here, there seems no reason to be limited to the fast start unit as well. It seems it applies to all the unit that we can potentially include the unit commitment cost. But yeah, I would defer that to the policymakers. Then that will significantly extend the scope we're considering here. My last question. Sorry for asking many questions here. So is this scenario that you're presenting part of a design that we'll consider in the fast start pricing, or that's just a assumption that we make when we do the analysis?
Well, this is like the chicken and the egg, right? What comes first? If we go through all the policy discussion and we determine that we want to take one approach, then the question is going to be, how does that make sense, right? How does that work for the case? So what are the implications based on the actual conditions and model and resource that we have? So we may have to go back and do the analysis, or the approach that we're trying to take that, well, we need to take some approximation of potentially what faster pricing could be to get a sense of how this may look like and the implications, and then be better informed to push forward the discussion of the policy, right? I don't know if that is going to put us eventually in a better place. I would say it will, because at the end of the day, there are so many permutations you can do for faster pricing, and for analysis at the end. Again, we have to come with one approach, right? We cannot use 50 different approaches to see which one is more effective or is capturing. There are many salient features that I indicated at the beginning of this presentation that are here, not because we believe that is the right approach to do in terms of the policy, but because we have to come with something for the analysis that resembles, that captures the essence to some extent of the fast start pricing. To your point, everything is on the table. This analysis doesn't indicate that this is the way that we should do it. It's a way that we can assess the potential implications, but it's not the only one or the right one to take it at this stage of the discussion.
Gotcha. I appreciate the answer. Thanks.
Well put, Guillermo, and thanks for the questions, JK. Mark, I see your hand up, but Mike, I'm not sure if that is in response or a legacy hand from your last comment. Okay, there we go. I saw your hand go down there. Let's go ahead and unmute Mark, please.
Hi, Guillermo. So I understand you're trying to come up with a very simple amortization by coming up with a fixed adder. But is the implication of this that if the unit is turned on for 1 hour at Pmin, it still won't recover its minimum load cost and startup costs? Only if it's turned on at 450 megawatts would it recover? And if the answer to that is yes, which I see you shaking your head, then we're still going to need bid cost recovery for that 1 hour Pmin run, correct?
Correct, and that's a great point, Mark. Yes, the assumption here is that this is spread over the full range, all the way to Pmax. So that is a key point, that it wouldn't guarantee that the unit is going to fully recover all the costs depending on what range is operating at.
Yeah, so going back to PG&E's comment, if this was a block-loaded machine and it could only be run at 0 or Pmax, it would recover its full minimum load and stuck in that first hour, but that's the only circumstance where it would recover its full MLC and stuck. This is start cost. Okay, thank you, Guillermo.
You're welcome. And this is great because you start to realize the implications of this, right? That we have to boil down to what the specific features should be accounted for and conditions. So this is really the complications when we start thinking through how we can implement potentially a variation of the fast start pricing. Okay, do we have...
Before we move forward, yeah, we have James's hand up. James, go ahead.
This is James Schroeder from CAISO. I just wanted to add on to Mark Smith's comment that that comment is true for this hour period. But one thing to consider is that we have to decide how long does the fast start price signal stay in the market. For some ISOs, they amortize or continue to use the sort of amortized modified offer curve during the minimum uptime only, which in this case is kind of what's happening here, since the minimum uptime is an hour, and this is an hourly bid curve. But if this unit is online for 4 hours, say, it could recover its minimum load and startup costs if the modified offer curve is active for the entire 4-hour period, which some ISOs do that as well. As long as the resource is online, the modified offer curve is in effect. So under a 4-hour, if the unit is operating in 4 hours, it could recover its minimum load and startup costs for the duration of its time being online. So just a little caveat I wanted to throw out there. Thanks.
Thanks for that, James. Any reactions to that? Mark, I see you're still unmuted.
Okay, I didn't realize I'm still unmuting, but thanks, James. The opposite end of that, I guess, is that a unit could substantially over-recover its startup costs on an hourly basis if it ran for 4 hours and it was amortized only during the first hour using this simple calculation. So I think the opposite occurs as well. Okay, thank you.
Thanks for that, Mark. Sorry to put you on the spot like that. Appreciate the question and the reaction. All right, Guillermo, back to you.
Okay, let's move to the next slide, please. Okay, this is the second approach. I'm glad that Mike is with us today because that was his suggestion through some discussions that we have internally. Let me just summarize mechanically what is happening here, and I will turn it to Mike to see if he can give us some principles of why this approach is potentially superior to the constant adder. What this different scenario covers is a calculation that relies on estimating what we call the average cost. And the average cost is subject to where the unit is potentially operating at. It's basically assessed at each end of the segment of the bid curve. What you have here is first the estimation of the average cost. If the unit is operating, let's say, at basically the P-min, the average cost is going to be no more than the commitment cost, the startup cost plus the minimum load cost. If the unit is assumed to be operating now at the end of the first segment, at the end of the second segment, and so on up to the P-max, you start adding the cost associated with operating the unit in that variable range on top of the commitment cost. So you get this total average cost based on the operating point of the bid curve. Once we have that average cost, now we are going to basically get the average price, and that is just dividing it by the operating point. That is different than the constant adder because it was divided always by the P-max. Here you divide it by the specific bid segment you are assessing. You estimate an average price for each of the segments that incorporate proportionally the minimum load cost and the startup cost. What this means is that you are going to get a different adder for each of the segments, or a different cost for each of the segments. If we can move to the next slide, please. Just to illustrate graphically what this means. Assuming we have the market bid, now we are making an estimate of the average cost that is going to incorporate the minimum load cost, and that is going to basically decline, right? Because if you are operating at low megawatt value and you amortize or divide that minimum load cost, startup cost by that operating point, it's going to give you a value that is going to be higher than if you assume that the unit is going to be operating a higher point, because now the coefficient is going to be a higher megawatt. So you have this decreasing cost. When you put these two together, what you're going to get is the total minimum average price. And if you have this curve that is increasing versus this other curve that is decreasing, the combination of these two is going to give you this convex curve that eventually is going to have a minimum point. That is going to be the reference to determine what is going to be the other that is going to apply from that point on to the left and potentially to the right. Graphically, we can move to the next slide, please. This is how it may look like for the same scenario we were discussing in the constant other. Operator, next slide, please. We continue to have the original market bid that is in blue. Now the bid in gray stands for this average cost bid that we have. And we start with some high value that reflects basically only the minimum load cost plus the startup cost. And as we go through each of the segments, now we are appending the additional cost and amortizing over that extra cost for each operating point of the bid range. Eventually, there is a point that is the gamma sub m that stands for the least average cost in that estimation that will go from the Pmin all the way to the Pmax. And that is going to determine now what is going to be the striking point in the curve. And if we move to the next slide, graphically, we can illustrate this in this way. Effectively, the point of the minimum average cost is going to define the left-hand side of the bid, because we already identify what is the price, the energy, the production point that achieves this least cost. You can assume that that is going to be the minimum point to consider in the curve. So anything on the left is going to be set at that cost. And after that point, basically, we have to see which one remains valid, whether it's the original bid or this estimated bid. If we move to the next slide, this is going to show effectively the final bid. In the lower part, we continue to have the market bid that goes all the way up to the minimum point. We also have, for comparison, the original constant other bid. And this modified bid effectively is just a flat range all the way to the minimum point of the cost, and then basically overlap with the market bid. And in this case, we are effectively continuing to use the original market bid for any point that is beyond this minimum average cost, because effectively you can still recover or cover the cost with that original bid than using this average cost. Mechanically, this is how the second option would look like in comparison to the original market bid, in comparison to this simple constant other that we have. And effectively, what you're going to see that is going to land to different results, because one bid is going to result in higher price than segments, and if they are eventually setting the price is going to be set to a higher value. Mike, do you want to provide any comments on the principles of this proposal that you have regarding the average cost, the minimum average cost?
Sure. I mean, one of the problems that we have to confront if we were to do fast start pricing is that, we're basing the dispatch of resources upon one set of offers that reflects, physical constraints on operating various resources. And then we're calculating prices using a different optimization, which relaxes some of those constraints. And so we can get inconsistencies. We can get inconsistencies between our schedules and our prices. This is always a problem whenever you're calculating schedules in one run and prices in another run. And so the idea here is to try to minimize those inconsistencies, essentially to the extent that we can, to make the adjusted offer curve that is used in the pricing run consistent with the actual offer curve that is used to determine dispatch schedule. And so we have a couple of principles we have to, that the adjusted offer curve has to live by. One, it needs to be in, increasing offer curve, or else the software won't like it very much. Non-decreasing, to say it more specifically. And secondly, we don't want to artificially make the unit appear to be more expensive or less expensive in the pricing run that it was in the scheduling run. So we want to have an offer curve which, when the unit is at full output, would have the same cost of operating the unit as what we would have had using the actual offer curve. But then the third constraint that I'm introducing here, which leads to this average cost approach, is to essentially, minimize the extent to which the adjusted offer curve and the actual offer curve differ. And that's what this does. And so if you take a look at, say, the right end of this graph here, we're at the last segment of part that gets you to 450 megawatts, the actual offer curve that was submitted had a cost of $80 per megawatt hour for that segment. So it costs that unit $80 to go ahead and produce additional energy when it's at that level of output. So let's suppose that it was in the dispatch, the ISO was choosing between that and some other resource that had offered 90 megawatts. Well, it would choose the $80 resource. But then we would turn around at the pricing run and we'd say that, gee, now we're going to look at it as though that's a $95 cost, $80 cost. And so we wouldn't choose that, and we would choose the $90 resource instead. We have a situation where we're dispatching the $80 resource and not the $90 resource, but we're having the $90 resource at prices. So the idea is to try to avoid that situation to the extent that we can. And so that's really what the average cost pricing approach does. It essentially brings the to the extent that we can, consistent with the first two principles that I stated, which is not to artificially make the unit cheaper and to have non-decreasing cost curve. It establishes an adjusted cost curve that is consistent with the actual offer curve, so that we can essentially minimize the extent to which we encounter inconsistencies between the dispatch and the price signals. And so that gives us, it's more efficiently recognizing the fact that the marginal cost of generation at that point is $80. So I think it gives us more efficient signals. It avoids these inconsistencies, which can in turn give people incentives to do things that are in their own private interest, but are not in the interest of essentially operating the market as efficiently as possible. And thirdly, depending on exactly how you implement the flat adder approach, there are ways where that can be gamed to produce really large adders that don't adversely affect the likelihood that your unit will be committed. This approach would combat that, so it's less susceptible to gaming. So those are the reasons why I think it's worth considering.
Thank you, Mike. Juan, can we check if we have any questions about this?
Absolutely. So again, if you have any questions and you're in audio only, Town 2, feel free to raise your hand as Callie has here. Let's go ahead and unmute Callie, and then you can also send it into the chat. So let's toss this over to Callie, please.
Hi, it's Callie Wells with WPTF. I just have a quick question. I want to make sure I understand the main distinction between these two approaches from a pricing perspective. So looking at this average bid curve, the second scenario, am I correct in understanding that we will only see a price difference compared to what we see today when this resource is operating at about, I'm going to guess, 260 or less? Because that seems to be where its original curve is increased up, and then the remaining part of the curve on the right continues with its original bid. Do I have that right, or am I missing something?
Okay, let me take it first.
I think Mike just came off of. Yeah, go ahead, Guillermo.
Yeah, is your question, Kali, if we were to implement this second approach, that we would only see a price difference when the resource is operating under less than 260 megawatts, because in that case, the bit is different, right?
Yes, because I was, in my mind, I'm trying to tie it back to kind of some of the BCR metrics you guys were showing and trying to get a sense of what kind of impact this would have on bringing those BCR numbers down. I wasn't sure if you guys had taken those numbers and broken them out to resources that are operating kind of at their PMIN or lower operating range versus higher operating range.
Yeah, but I can tell you conceptually what could happen, right? And if we take this at face value, and these are the bits, and now you were able to run counterfactually the market for each of the bits, if the resource is going to be dispatched anywhere up to, let's say, 260 megawatts, and they happen to be the marginal resource, effectively, that is going to set different prices depending on what type of bit we are using, right? If you just draw a vertical line, let's say at 200 megawatts, you can see what is going to be setting the price. Again, if this resource happens to be the marginal resource, if we just use the market bit, it's going to set the price at $40 versus, I don't know, 50 plus dollars using the second constant and the average approach, or it could be up to maybe 65 and slightly higher if we use the standard adder, right? But the key point is that it has to be the marginal resource. And there are some interesting interpretations that you can see that once you modify the bit, because it's now how you reconstruct the bit stack and where that capacity is going to be located, right? Because by the time you introduce this resource with a higher bit, potentially what is happening is that now you are making these economical movements of generation, right? If there was another bit that was slightly cheaper relative to the original bit, now that bit comes first, and potentially that is going to set the price. So it realigns the bit stack. So it's not granted that because you change this bit, now this is becoming the marginal resource. It's now how that is located relative to the whole bit stack. And I think I have an illustration just to show that in the next few slides.
Okay, yeah, no, that makes a lot of sense. I was just trying to think about the price formation part of it, and yeah, sorry, my assumption was it was the marginal resource. So okay, no, I appreciate that. Thank you.
You're welcome. I think we have one from Mark and Juan.
We do, absolutely. Thank you, Callie. Let's go ahead and unmute Mark.
This is really a question back to Mike, I think. So if a resource is in fact dispatched up to its Pmax with this average fast start pricing bid curve, the modified bid curve, how does it collect its start costs? It is running at its marginal bid. Let's assume it's the marginal unit. It appears that if it's run to Pmax, it wouldn't recover its start cost.
No, it should. I mean, this is harder to see, but if you flip back to slide, I think 29.
Can we go back a couple of slides, operator?
Yeah, there. So we actually have in gray what's mapped as the average cost at various output levels for this unit. So you can see that it's, if we're at a point where it's operating up at its Pmax, its average cost is going to be considerably less than the revenue it's collecting. So it should be recovering its startup cost and somewhat more.
So when you're saying average cost, you're not talking about the average of the minimum load and startup cost. You're talking about its marginal production cost.
Can you say that again?
When you're calculating an average cost,
yes,
you're not talking about the average of the minimum load and startup costs, the $7,000 over the 4,500 or 450. You're talking about the production cost, the total production cost?
I'm talking about essentially what the MLC would be plus the share of the startup cost that has been allocated to, whatever point in time we're looking at, whatever interval we're looking at, plus whatever incremental costs above operating at PMIN are. So all that, so your total production cost divided by whatever your output is at any point in time.
Yeah, so why wouldn't the modified bid in the next slide at the highest level be a small increment higher than the marginal cost bid at $80 on this slide?
Because we've recovered all your cost at the average cost minimizing level, which was, what was it, the $260, $270 level, 270 megawatt point. At the point where these gray and these blue curves intersect, that is the point that's minimizing your average cost, which we've covered at that point. We've covered your startup costs, those aren't varying. We covered MLC, that's not varying. And we covered incremental costs up to 270 megawatts or whatever that quantity is. So all those costs have been covered by that point. You don't need to go ahead and increase the demand curve to the right of that 270 megawatt level to cover those costs because you've already covered them.
Okay, let me ask the question just more simply. Without any adders, your cost for PMAX is $80 on this chart. With whatever this average cost adder increases, your cost is still $80. It doesn't give you any incremental cost recovery at PMAX.
It doesn't provide separate incremental cost recovery because at PMAX, if you're operating at PMAX and the price is $80, you're already recovering all of your costs plus more. You're already making a positive profit. You are whenever you're on the margin and you're being dispatched above the average cost minimizing level. You're covering your share of the startup cost allocated that hour, the MLC, and whatever incremental operating costs you have above.
So you're saying that the initial bid cost submitted is not purely marginal cost of generation. It includes somehow or other some recovery of minimum load and startup costs. I'm sorry, I'm not understanding what happens at the higher end of this, and maybe we should take it offline.
Yeah, well, what happens at the higher end, once we get past the average, so what we have is essentially, if we can go back to slide 31. Yeah, so what's happening to the left of 270 megawatts is essentially, that is a calculation. I'm not sure exactly what the number is, but it looks like it's something in the low 50s. You will recover. That is the point that minimizes your average cost. So that at 270 megawatts, your total costs of operating are going to be your startup cost, your minimum load costs, your incremental output cost, divide them by 270 megawatts, we get to $52 a megawatt hour or whatever the number is, 52. So the offer curve is $52 to the left at that point, recognizing that if you are asked to operate at less than that level, you will not recover your costs according to your marginal offer curve. And so the adjusted offer curve is higher than that. And then to the right of that, the adjusted offer curve would match the actual offer curve because those are points where you already achieved. You won't have a situation where you won't have recovered your costs. You will have gone ahead and recovered your min load costs and your share of startup costs. And so there's no need to include an additional adder to permit recovery of that. That's already going to be recovered if the price is high enough at that output level to permit. It's probably easier to see with an example of fewer steps.
Okay, so the only thing I can assume is that your initial bid curve included some estimation of your marginal minimum load costs and startup costs, because at 450, the price level doesn't change. The bid price does not change.
I'm assuming the original bid curve, the MLT was your cost for operating at PMIN, and then that the incremental steps are reflecting what your incremental cost would be of operating at various levels above PMIN.
So it's not merely heat rate times gas price. It's something else.
It is whatever your variable costs are. I would assume if you're a gas-fired unit, those would be the primary ones. But
Okay. Thanks, Mike.
you're welcome.
Thanks, Mark. Okay. Guillermo, no other hands or comments in the chat?
Okay, let's keep going. Can we move to the next slide, please? Let me change topics. And this is not specific to the nature of the adder, to the nature of the calculation of the adder. It's how we can continue to apply whatever logic we end up using for the startups to what we call the multi-stage generator units. Here is a very simple representation of, let's say, just two configurations, two states for MSG unit. We have 2x1 and 3x1. There are many more configurations available in the market, up to 10, I believe. And when we're making a transition, going from one configuration that we typically refer as the from configuration to the next configuration, that is the to configuration, there are some discrete conditions happening. The unit cannot operate between the configurations. That is what in the past we used to call the forbidden zone. We indeed have a model that was called forbidden zone because we didn't have the MSG model. And in that range, the unit is really just making the transition from one configuration to the other. And by the time it has to make a transition, there are transition times. It takes certain time to make the unit to move between configurations. There is potentially some transition cost. It costs money for the unit to make the change of state, because it may have to start up another jet that makes now the 3x1, right, rather than the 2x1. So similar to the startup cost. And by the time it moves into the two configuration, now it's going to be operating at that range, and there will be some minimum load cost. There was a minimum load cost in the from configuration. There will be another minimum load cost in the to configuration. And as you can see, there is a lot of analogy to when we make the determinations of commitments in startups. And the question is, if we have this specific model allowed in the CAISO market, and we have a relatively healthy volume of capacity related to MSG units, should we incorporate some type of fast start pricing logic also for MSG transition, similar to startups? That is still an open-end question that has to be addressed eventually through the policy discussion. What I can tell you is that we have incorporated some type of logic to model fast start pricing for specifically MSG unit transitions. With this construct, let's move to the next slide just to tell you graphically what we have done to incorporate FSP into the MSG into the FSP. Here we have either the constant adder or the average adder that is going to give you a different bit, and that is the upper part of in purple in the 3x1 configuration. It's just a higher bit one way or the other, one adder or the other. And now the key component here is how do we model the forbidden zone or anything that is behind the PMIN of that configuration. There is a PMIN for the plant, and there is a PMIN for each of the configurations. When we're moving into a new configuration, we're really talking about relative to the PMIN of that two configuration. In this case, it's a PMIN of 300 megawatts. Very similar to what we do for the startups, we're going to stretch that range, that modified bit, all the way, not to 0, but to the Pmax of the from configuration. If the unit is operating at least at 300 megawatts, that was a commitment decision made by the market. The market cannot just start dispatching that unit anywhere in the range of the 2x1 configuration. It has first to transition the unit into that configuration to be dispatchable. So you can see that anywhere between 0 to the Pmax of the from configuration is like a fixed block range of capacity that is indeed not available for setting prices, neither for dispatch in the market. So what I found to be more logically the extension for faster pricing is that we extend the Pmin of the to configuration all the way back to the Pmax of the from configuration. And in that sense, you can get an idea that it's like having a continuous bit range for this MSG unit. We expand that Pmin from 300 to the Pmax of the from to 200, and that is indeed that flexible range in which we can model the unit to be flexible for setting the price. And it's going to be using the extension of the first adder, whatever that is the constant adder or the average adder. And that is effectively what we have done to incorporate faster pricing for multi-stage generator units. Next slide, please. There are more nuances, and this is something that, again, may be subject to down the road discussion because there are more about the implementation details. One complication is that things are more complicated for MSG units. There are many configurations available. In some cases, there are configurations that are overlapping. That means the Pmax of the front configuration may be higher than the Pmin of the to configuration. So you have this overlapping range. In that sense, how do we model the faster pricing? Well, we can continue to apply the commit cost by the adder, but there is really no flexible range to expand, right? Flexible range to consider the pricing run because you are already in that operating range. That is a simple approximation we can do. And then there is a kind of open question that we didn't explore further in this analysis, and that has to do with the downward transitions. It's very logical to extend this when we're dealing with upward transition. You go from a lower range to a higher range, so it's kind of starting up. However, when we are dealing with downward transitions, it's not that obvious that it should apply the same way because you are going down. You are going from a higher range to a lower range. It is not analogous to a startup. It's more analogous to a shutdown, and we don't have FSP for shutdown. So for this type of analysis, we didn't apply any logic to the downward transitions of MSGs. And that is something that we may have to consider further if there is any level of implementation we have to consider. It just doesn't feel natural to apply the same way the logic that we have for a startup, just because, again, you are going in the shutdown direction rather than the startup direction. If you were to extend the range, what range would you extend? Would you extend the Pmax actually of the front configuration to the Pmin of the to configuration? It's just very confusing whether it should apply or not. So again, for purposes of this analysis, we only apply this to the upward transitions. We didn't apply this to the downward transitions precisely because of these complications. And it goes also to the core of the discussion of the definitions. Do we use only the transition time? Should we apply that concurrent with the minimum of time of the two configurations? There are more nuances that we may have to explore if eventually there will be some type of implementation for faster pricing. Next slide, please. This is how it looks like in practical terms when we apply the constant adder, the average adder to a startup, to MSG unit, and it's kind of crowded. This is the bid stack that we have for the real life market of October 19, now ending 18 is the first interval. And for reference, you have the three colors. One is the original market bid. The second one is if we were to apply a constant adder. And the third one is if we were to apply the average adder. And each one has its corresponding color. And you can see that there are some interesting points here to highlight. The first one is that there is a shifting in the range of PMIN and self-schedules because when we start incorporating fast start pricing, we are modeling the range of 0 to PMIN for those units to be flexible. That means it's no longer as a block capacity in the PMIN range. It's going to be somewhere part now of the bid stack of the supply. And that is the reason you have this shifting. That is how much between 0 and PMIN we are now modeling as flexible as part of the bid stack rather than as the block at the bottom of the PMIN. And then you can see that the green and the blue kind of start at the same place. They are basically giving you the same answer all the way up to you reach maybe the range of 35,000 megawatts where they diverge. And the one in green, that is the constant adder, naturally tends to be higher because of what we explained earlier today. And if you keep going a little bit more on the higher end of the bid stack, you can see that there is more price separation. What does that mean? That if we have specifically the demand level in this case to be somewhere about almost 36,000 megawatts, the intersecting point of that vertical demand line against each of the bid stacks is going to give you different prices. Is the standard price of the market bid, the standard pricing versus the one in blue using the average adder or the constant adder. And that will give just different prices for each of these scenarios. And that is expectation. You are adjusting the bid stack, the bid supply, that is going to clear at different levels to reflect that and consideration of the commitment cost relative to the original market bid. The consequence is going to be that we're going to be clearing at higher prices for the same demand level. In this case, the original market price was a little bit under $100. With the faster pricing, either option, you are going to be in the range of 120, 130, or something like that. Let's move to the next slide. Another detail in terms of how we have modeled this analysis for fast start pricing. The power balance is potentially the most critical component, right? What considerations we have for the power balance? Well, we consider all the supply internal to the area, in this case, internal to the CAISO area. We consider the imports, the exports, either as supply or demand. We consider also the transfers that are coming in or going out of the CAISO area. We consider the transmission losses as part of the solution. From the scaling run, we already know how much losses are estimated for the transmission system. We already know the scales of the demand from the pumps. And we actually incorporate also the load conformance that is used in the market that is effectively pushing the market to clear at the higher levels, accounting for this additional consideration of the conformance. When we're clearing the 15-minute market, some of those factors are given, are constant, such as the imports and the exports. If they are hourly transactions, they already clear in HASP. They are not re-optimized in the 15-minute market, so they are modeled as fixed, as constant. Same thing for the losses, for the load conformance, for the scales of the pumps, and the transfers, in this case, to incorporate the dynamics of the EIM market are considered to be also as given. We are not changing the optimal transfers that are happening in the EIM market. We're just trying to discover what is the price by factoring in the capacity that they have displaced by having extra imports or having extra exports coming in or out of that specific area. And this is the way we have incorporated the different factors that impact, at the end of the day, the supply available to form the prices in the counterfactual. Next slide, please. And the last piece has to do with minimum online constraints. I already explained that yes, it's a factor, it's a driver, mostly impacting the day ahead commitments and revenues and costs, because that is where they are decided whether they are needed to be committed. When they come to the real time, they are not that relevant, because even if they were part of MOC in the day ahead market, and if they are fast start, nothing is going to come from the day ahead market to force these units to be online in the real time. They are going to be reoptimized based on economics in the real time conditions, and if the prices and the conditions are right, they are going to be dispatched. So in that sense, it's not really relevant to have this component of the MOC when assessing the real time conditions. Please, let's move to the next slide, please. Okay, here is the summary. Once you have all these bases, these foundational elements that we have discussed of how we built the scenarios, the conditions to estimate the implications of fast start pricing, we have a few metrics that summarize the main outcomes of this analysis. And the first one obviously has to do prices. How do prices change when we incorporate any of these scenarios? And here you are going to have a breakdown of 4 different scenarios. And it's a 2-dimension combination. One is the definition of the time, when the startup time and the minimum of time has to be less or equal than 30 minutes, or less or equal than 60 minutes. And the other dimension is whether we use this constant amortization versus the average amortization. That gives you the 2x2 dimension here in the metrics. And depending on where you are located, you can see the outcome of each of these 2-dimension combination. So if we took, for instance, the case of the upper left, we are analyzing the price changes or the price comparison for the specific scenario where we have the definition of the fast start to be a startup time and minimum uptime of 30 or less minutes. And we use the constant amortization. If you go down, the only change is that we remain constant amortization, but we change the definition of time to be 60 minutes, and so on for the others too. And the point of showing this illustration is the price comparison. The bars are the same, even though they are different colors for each of the 4 quadrants, they are the same. And they stand for the standard price when we don't have any incorporation of the commitment cost, just standard pricing. And then the dots with the trends in black stand for the prices that we achieve by using the specific definition of either of these 4 quadrants. And the point here is that if you look at just relative to the range of the prices, you can barely see that there is a difference, right? They are basically overlapping. You have the market at the end of at the edge of the bar, basically meaning the FSP price is kind of the same of the standard price. There are not dramatically different prices or high enough prices differences to be visible in this illustration. If we go to the next slide, that now goes into the relative differences that are more meaningful just because of the magnitude of the differences. Operator, next slide, please. Here shows the relative price differences. These are not the absolute prices. This is just the comparison between the benchmark prices, the standard pricing, and either of the scenarios for fast start pricing. When we have this definition of 30 minutes, basically there is very little change of price. You can see it's just noise in the lower end of the spectrum. More meaningful price changes happen when we start incorporating resources that have at least 60 minutes of startup time and minimum uptime. And the difference are going to be changing according to the time of the year. We capture here basically 2 years. And if you look at the highest value, it's in the range of maybe $1.25. That is an average difference. We have other metrics that show the individual differences, and in some cases they may range over $100. But on average for the month, you can see that the price difference is about at most $1.25, $1.3 that happened in the summer of 2022. And between the two scenarios of constant amortization and average amortization, you can see that there are, relatively speaking, in the same ballpark differences for prices. There is a different way to see the implications of the prices, and that is in the next slide, please. And that is on the hourly profile, and we organize this separate for each of the 2 years. This is 2022, and it gives you the trend on an hourly profile for each of the months of the year. And I would say it is kind of expected to see this pattern, that you're going to see that there are price differences that typically are going to be concentrated mostly in the peak times, either in the evening peak times during the summer, or also in the morning peak times in the lower shoulder months of the year. And it's kind of persistent trend. I would say it's expected trend to see these prices to work that way. And you can see, for instance, we have August 2022, right, when we were in the middle of the tight conditions of the summer. That is when we saw, on average, a price difference of up to $10. That means if we were to apply faster pricing during these tight system conditions, on average, we would expect to see up to $10 price higher for the peak time of that year. If we move to the next slide, it's the same representation, but that is for 2023. And we incorporated only the available months. We are missing, obviously, December. Next slide, operator. And you can see that the trend is kind of very similar. We are peaking at the peak hours of the day, anywhere between hour ending 15, 16, all the way through hour ending 20. The magnitude is not that different. Here the maximum is about $6, $7 in the August 2023, again, when we were in these high load conditions. There are other months like March that are quite interesting, because you can see that there are prices going up in the morning peak. And this is the time of the year where we start to see this shifting of the load profile. So it's not so surprising that we're going to have startups, transitions that eventually can become more marginal for this time of the year. They're still contained within the same range of price differences. And for other hours, like in the middle of the day, or the shoulder hours, the first hours of the day, the last hours of the day, you see very little changes. And that's expected because there are not many startups or many transitions happening in these hours, at least not in the direction that is going to induce the fast charging to set the price. Next slide, please. And here is another metric, and I have to put a lot of caveats for what these numbers really mean. It's the same construct, the same 4 permutations that we have. This is a simple calculation of the real-time cost. And it's an absolute calculation, because it's simply taking the demand obligation that we have times the clearing price. Clearing price using any of these 4 permutations of the scenarios that we described. Now, that gives you a reference of if we were to settle everything just on the real-time markets, this is cost-wise how different using faster pricing would be. At most, you are ranging potentially in excess of $30 million in August 2022, again, in high load conditions. We expect to see that it's going to be more spiky, more sensitive to price, because you are in the steeper range of the bid stack. And so small changes are going to have more meaningful price changes. Now, this is absolute, assuming that everything is settled at the real-time prices and all the demand is settled at the real-time prices. Our market is more complicated. we don't settle in absolute terms for the real-time market. We have this multi-step settlement calculation where we settle first the day ahead, then the differences of that day ahead versus the real-time are settled at the real-time prices. So in the next round, we expect that we can go that extra length to try to mimic more closely to what the two-step settlement actually is. This just gives you a good reference of magnitude-wise if everything is settled at the real time, how meaningful it would be. Once you start going into settling differences of schedules and prices, the picture may be quite different. So I want to put this with the caveat that is relative to the absolute cost of the real time. Next slide, please. And the last piece is the implications for flexible ramping product. We optimize the clearing of the energy and the flexible ramping product capacity. We are doing that nodally since February 2023, and it has changed somehow the dynamic of the market. There will be capacity utilized for meeting the requirements for flexible ramping capacity. That capacity is going to create some type of opportunity cost between procuring energy or securing that for FRP. What we have done, as indicated earlier, is a basic approximation of the economic displacement of FRP. So we are taking as given effectively the flexible ramping capacity awards, taking that away from the available bit range of the supply because it's no longer available, it has to be reserved for flexible ramping. And that way, it's a simple way to incorporate the opportunity cost that the FRP represents. And when you see how frequently there are prices differences because of the FRP, it's less than 10%. And that is not that far away from what we currently see in the actual production system where non-zero prices for FRP are contained a very small frequency range, less than a few percentage points. And that is the way we have incorporated the implication of accounting for flexible ramping products. And I believe that's all what we have in the scope for this presentation. I think we are good for taking questions and comments. And Juan.
Very good. Thank you, Guillermo. We do have a hand up, so just, again, everybody, if you've dialed in, #2, feel free to put your question in the chat, but we encourage the actual verbal question. It could spur on some additional conversations. Let's go ahead and unmute Callie, please.
Hi, it's Callie Wells with WPTF again. I have a couple questions, and the first set of questions are back on slide 40 and 41. So I guess the first one is just a clarifying question, and I probably missed it in your discussion, so apologies if that's the case. But are these based on the average or the consistent approach? When you looked at the change in prices, did you guys, which FSP approach did you apply?
Actually, we apply both, and there are 4 lines in each trend, Kelly. They are maybe overlapping too much, but I can tell you the 2 lines that hover around, let me step back. There are 4 dimensions to this representation. We are showing the 2 approaches, the standard, that is the constant. Well, I should have called this constant rather than the standard. The standard is the constant adder. And then the other one, AVG, is the average adder. These are the 2 others that we discussed. And we are also putting this for the 2 considerations of 30 minutes and 60 minute fast start. When you see the trends for any of the months, let's pick, I don't know, December 2022, there are kind of 2 lines that are hovering around 0. These are for the 30 minute, both standard and average. And then you have 2 other trends in red and turquoise, blue, that are non-zero. These are for the constant and for the average. So the one in red that is lower than the blue is the constant. The one in blue is the, is the other way around. The average is the red one, and the blue is the standard one. And that is expected, right? We are going to end up with higher bits for the standard constant adder, and that is going to lead to higher prices. So that is the profile that you see there. So it includes all the 4 scenarios that we discussed.
Okay, thanks. Yeah, I didn't realize that the standard was the constant approach. So apologies for missing that in the legend there. Okay, so thank you for that one. And then my question on this is, obviously you're reporting out on the average price increase. And so some of these high prices, or the increase, I'm just going to throw, like a $5 average increase. Do you have a sense, is that driven by a few instances of really high price increases, or is it more that you actually have several instances in that month where you do see a price increase around, the $5 to $10 range? So I guess an idea of the distribution.
Yes, and we try to put some distribution plots, but they are so skewed because the majority of the prices are the majority of the price differences are contained in a small range around 0, and there are some high prices. So when you see the plot, it just looks like a line. There is really not much distribution. So the majority of the differences are small. There are some larger differences. So maybe we can try next time to show in some way that distribution. It was just not very meaningful graphically showing that just by how they were distributed.
Okay, I appreciate that. Yeah, that would be tough to show. But yeah, if there's a way to kind of narrow in on kind of the distribution in some way to get an idea if it's just really a couple key instances that are driving these average prices up, or if it is more consistent, would be great. Yeah. And the last question, I guess maybe it's more of a comment for the next iteration of analysis, is on slide 42 when you showed the cost to the market under the FSP approaches. So I understand that the way you calculate it here in this chart. So would another further step to really understand the full cost implication is also looking at the impact this has on BCR, right? Because the theory is you end up with higher prices, and while you might see a higher energy cost in that chart you showed, we might actually see a decrease in BCR cost as well. So it's more of a cost shifting rather than just a pure cost increase. So I guess that's an ask if there's a way to fold that in maybe in the next analysis that you guys put together, would be useful.
Yeah, thank you, Kelly, for the suggestions.
Okay, great. Yeah, that's all I had. Thanks, Carol. And again, thanks for pulling these numbers together.
Yeah.
Thank you, Callie, and that kind of leads right into the next, area of this working group session today, which is suggestions for further analysis or refinement of this analysis. So before we move there, any additional questions for Guillermo on what's been presented here? Okay, Guillermo, we do have one here in the chat. Does the price increase, so if we can move to slide 39, does the price increase on slide 39 and the incremental costs on slide 42 include mitigated cost of BCR or other costs that fast start pricing could reduce?
Sorry, Juan, I couldn't catch fully the extent of the question.
Yeah,
Could you
let me
read that again?
Sure. So we're looking at slide 39 here. And then I guess if we could move to slide 42, because the question is kind of comparing the two. So the question is, does the price increase on 39 and the incremental costs on slide 42 include mitigated cost of bid cost recovery or other costs that fast start pricing could reduce?
No, it doesn't include that yet. And that is the reason I was putting the caveat. That is just absolute cost relative to the demand in real time times the new prices in the real time. So we will do more work to try to incorporate that in the next round.
Go ahead. Oh, there we go. Let's get myself off of mute. Not seeing any other questions. Guillermo, Michael, or Mike, Quinn, thank you very much for this presentation. We sincerely appreciate you guys. I know this is a very large effort, and it's appreciated. So this is a great starting point to continue this discussion and this analysis. So if we could go ahead and move forward in the slide deck. Guillermo, do you want to cover this one, or would you like for me to kind of use this to lead into the discussion?
Oh, this is just closing remarks, so I think we can skip it safely, so we are good.
Okay. So if we could go ahead, and for those of you who are on the stakeholder page, you'll see a couple appendix slides. So let's go ahead and let's move to slide 49 for now, if you don't mind. I did see James's hand pop up. So James, please go ahead.
I want to take a moment to communicate that we will be chatting about the same topic at the Market Surveillance Committee meeting on December 18th, which is next Monday. I think it's 9 to noon Pacific time. Thank you.
Thanks, James. And we'll add the pertinent meeting information to the chat on that MSC meeting coming up next week. All right, well then with that, let's go ahead and move to the next slide, which is our Slido poll. Want to hear from this community, you know, what additional feedback or information you have to refine this initial analysis. Again, we're taking an iterative approach to this. So this is an open-ended question. If you have a comment, though, and you want to go ahead and raise your hand, you're welcome to do that as well. We're also going to be sending out a survey following this working group meeting to capture this feedback. Now, I want to be very clear about this. The survey itself will have the results posted to the actual initiative page. So again, our aim here is to kind of refine this initial analysis. We're looking to scope analysis on fast start pricing to continue a robust discussion on the topic. So let's give this a little bit of a moment for people to give their feedback here on how we could refine, what additional data slices would you like to see, what might kind of continue to inform this discussion. Now, again, we do kind of have a sense of ideas moving forward, and that'd be to fully assess the WIM areas. But what further cost implications would you like to analyze? What other feedback do you have for us as we move into the next stage of this? All right. So they're starting to come in. I appreciate it. The first one I see, there's a great deal of detailed information being presented in comments. Many of us are multitasking out of survival. Can the recording be posted, please? Absolutely. Not only will this recording be posted, but you will be able to leverage. We're going to start using chapters on our YouTube videos. So while we had a 3-hour-long working group session here, you'll notice that we're chopping that up. That's for just kind of a quality of life, ease of use for the stakeholder community. That's something that's relatively new for us. So we will get this recording posted, and you'll have opportunity to review that, as well as come back to us on the survey. Impacts to BCR, I think that's definitely an item that we heard a couple of times here. So Stuart Kelly from LA, price increases need to be offset with BCR for the same set of resources. What are your initial conclusions from this analysis? So Stuart, I think, I think that one's more of the actual policy discussion, but I do want to toss this one over to the ISO SMEs. James, Guillermo, any reaction there?
This is James, and I'm not sure at this point if we have the full set of information enough to make any sort of initial reaction. And part of what the purpose of today's discussion is, as Guillermo mentioned, is to sort of lay the foundation for what we would tackle in the final analysis. And then once we have sort of that more complete set of evidence, we can begin transitioning into discussions about, what it all means and how we should think about the results.
Thanks, Judge. I do see Stuart's hand came up. Could we go ahead and unmute Stuart?
I guess the objective here is we have identified a missing money problem, and we feel we need fast start pricing to fix that problem. Is that a fair statement or not? Or what is the objective with the fast start pricing?
Well, James, feel free to jump in, or Guillermo, but I think the objective here, Stuart, is to have the community help us define a scope of this analysis so that we can have that conversation, and we can have that conversation be informed of what problem statements do exist, if they do or not, identify the issues. So again, I think Guillermo, referenced it as a little chicken or egg earlier on the call, but we're trying to scope out an analysis to have that informed discussion. Guillermo, James, please feel free to weigh in on that.
I think broadly, or go ahead, Guillermo.
Oh, go ahead, James.
I was just going to comment that, broadly, I think I'm not going to call it a problem statement, but the motivation for investigating fast start pricing is that, there's perspective that, fast start pricing better and more appropriately compensates resources who are being operated at times when you're dispatching these fast start units to meet load in tight conditions, and that can be seen as sort of, in the chart where the fast start pricing effect is larger during the peak periods of the day. I think that's kind of what we're investigating, and here is to identify the metrics about what the impacts would be of trying to incorporate more of those commitment costs that are not recovered through the LMPs and are instead recovered through uplift payments, and what that impact would look like if fast start pricing or some form of it were in place to sort of shift that bucket of costs from one place to another.
That's helpful, James. So in a nutshell, we're looking at this through the lens of a better method of compensation. This isn't to do with concerns about the lack of incentive to invest in generation in some way. Is that correct?
It's a hard question to answer, the second part, because I think that the question about, or the comment about incentive for investments in generation may differ depending on which entity you're talking about, be it inside the CAISO, subject to resource adequacy, or outside of the CAISO, may have different perspectives on to what extent the pricing relates to incentives to build. But I think that you're on the right track, that we're investigating whether or not, fast start pricing, it comes down to a compensation issue and whether or not fast start pricing provides more appropriate and effective compensation for certain resource attributes.
Okay, that's great, because I think when you bring in the BCR, I don't know how much it moves the needle on the missing money problem from the data I've seen. So I now know what lens to look at this kind of issue through. So thanks, James.
All right, so we do have a lot of other calls here for supporting analysis on the impacts to BCR payments. That's a pretty common theme that we're seeing here. We have I'm going to just finish up the interplay. What interplay does CAISO see between fast start pricing and model changes and intertime market liquidity? Does more accurate pricing internal to the CAISO support attracting non-RA supply at the interties during tight Western market conditions? Dan, maybe you could help me unpack that one a little bit as far as how we could show that within the analysis. Great feedback, everybody. Vijay, we appreciate the opportunity to present this feedback and to continue this discussion. So do we have any other people still inputting their feedback into the tool right now, Ahmed?
Currently 2 people typing.
Okay, very good. Let's go ahead and give that a moment. Anybody care to break the radio silence and raise their hand? See if we can foster a little dialogue here. Again, this is for the stakeholder community here to let us know what this iterative approach to this fast start pricing analysis should look like, and how we can provide the information needed to have that robust discussion. I think we had some really good commentary as we kind of went through that presentation, as well as some requests for that refinement. But if there's anything else that you would like to see, again, you are also going to have the opportunity to comment via a survey that will be sent out to you. And again, I want to iterate, because the last survey that we sent out via SurveyMonkey was for BAA level market power mitigation. That was more kind of an information gathered. The survey results here we would publish onto the initiative page. So stay tuned for an email blast on that here shortly. So Mary, I appreciate you raising your hand, and Dan, very good. Why don't we go ahead, let's start with Mary. Let's unmute Mary, and then we'll move on to you, Dan.
Thanks, Juan. This is Mary Winkie from the Public Generating Pool, and I probably don't have anything quite as constructive as you would like, but did just want to say that we really do appreciate this effort and really taking an analytical approach to this as a starting point. Just really appreciate the effort that's been done, and think this is, very helpful to better understanding of kind of the questions that Stuart was raising, and where we kind of provide some really informed policy recommendations with this analysis. So just wanted to appreciate the work done and support continued efforts along the lines of what folks are suggesting.
Well, thank you for that, Mary. I really appreciate those words, and I'm glad that we're in essence hitting the target, right, which is to give a lot of food for thought so that we can continue to have these discussions. So let's go ahead and move on to Dan. Let's unmute Dan, please.
Hey, thank you. This is Dan Williams from the Energy Authority. So I guess I fall in that camp of folks who've been multitasking for survival. through many different things. So I hope this isn't too far out of left field, but just echoing what Mary said as well, supporting the effort that went into this and to the setup on the front end of this as being an initiative and exploring what could be useful. And one of those things for me, what I was trying to get at in the comment that I put in the chat is just thinking broader than BCR and sort of the impacts internal to the CAISO, and to think about also kind of the indirect benefit that quote accurate pricing gives in more of a interregional context. So thinking about resources, suppliers that are making consideration of which market they direct their supply to, how fully they participate in, say, EIM with their resources versus looking at, intertime market opportunities. To what extent, does improving the pricing model in any number of ways within the CAISO help foster liquidity at the interties when it matters most during tight supply conditions? So that was where I was going with it. I know it's not a quantitative, metric within the analysis, but it could be part of thinking more broadly of the benefits that this could bring.
I sincerely appreciate that, Dan. And it doesn't have to be that, that quantitative. I think even just directional, that helps the conversation. So I appreciate those comments. Thank you very much. JK, let's go ahead and unmute JK.
Good morning. This is JK Wang from PG&E. First of all, appreciate CAISO having this working group again, help us to review the assumptions and provide a comprehensive analysis. My request is, actually, personally, I find I learn a lot of things every session, and I wonder if we can actually take one step and going back. This analysis is very comprehensive. It's looking at the whole market, but even like through some internal discussion, we find we still have more basic questions about the definition of the fast start pricing, especially like when we go through the assumptions today and understand like we're not just looking at block loaded units. So if we can, have another session like going back to the very basics, how do we define the fast start pricing? Especially, my understanding, this is not just like, this is not exactly like the other initiatives like we have a new product or anything else. It's a new pricing mechanism. So for some development like that, the simulation model may be very helpful. Like if we go back to rudimentary examples, like with smaller size of a system, 2 or 3 nodes, and the basic models and designs, like PG&E mentioned in the comments, the CAISO can present like 2 to 3 representative designs at the fast start pricing. And let's start from there and say these are models we're looking at. And then we can understand better how we can project those basic models to a bigger market. Because when we look at a comprehensive analysis like presented today, apparently heavily depends on assumptions, which can bifurcate like in many different ways. So my request, pretty short, is if we can go back to the basics and help us to reestablish and better understanding the assumptions and definitions, that would be really helpful.
Yeah, James, I see your hand up. Please go ahead if you have a response there.
Yeah, thanks, JK, for the comment. One thing that can be helpful in the meantime, as we gather internally and think about your comment, are the series of workshops that we held last year, and I think even one early in the spring 2023, that dove into some of the basics of fast start pricing, whose assumptions and thoughts may have been lost now that it's December. That was, maybe over 9 months ago. But that could provide a helpful refresher for folks if you're feeling in the same camp here where you're wanting to refresh on some of those fundamentals. we can point you to those workshop materials. And then from there, whatever questions remain, CAISO staff are always happy to walk through specific questions. So just thought I'd point that out if that's a helpful reference for folks.
Yeah, thank you very much, James. We will definitely look into that. And, just another thing is, if you have initial designs in your mind, I know Guillermo presented some assumptions, but if, the policy people can also confirm this is sort of basic designs we're looking at to start from, that would be really helpful.
Yeah, and I can comment now on the block loaded part. So there was some information in the first couple of workshops where we looked at block loaded resource as a interesting subset of fast start resources because it's easy to explain the pricing anomalies or the pricing effects that happen when a block loaded resource is committed to serve load and how it's not able to set the price. But generally speaking, fast start pricing as implemented in other markets applies to all types of fast start resources and not just block loaded ones. So the example that we saw in the bid curve where you have a resource that has a 10 segment bid, if it meets the definition of startup and minimum uptime, even if it has a 10 segment bid curve, it's generally considered as a fast start resources as implemented in other markets. So I would think that the definition that we would look to incorporate would be inclusive of any type of resource that has the ability to start up and stay online for some period of time, and not just the block loaded ones.
Yeah, that's really helpful. Thank you so much, James. And based on his comments, I have another request. If we can say that in the future analysis, if we can have the generation portfolio in terms of how soon the resource started. I know something similar presented today, but if we can say, more more detailed classification of the generation fleets that's available in the market, like what each of the starting time is composes the generation fleet, that'd be really helpful.
Thank you, JK. Good feedback. We have that noted, and we'll definitely take that back for the internal discussion that follows here. Any additional comments? Okay, I'm seeing none. Let's go ahead and go to the next slide, please. So as James mentioned, we did have a couple of sessions in 2022 and then earlier this year. Brenda Corona has been kind enough to put a couple of those presentations as well as the YouTube links here in the chat. If you didn't get them in the chat or don't want to copy paste them, you are also going to have slide 51 here. We'll take you to the PFE initiative page, and we do have record of those as well. You just need to scroll a little bit down past the working groups, and you'll have all of those fast start pricing workshops where we kind of tackle some of those definitions, and that might be great reference material, as James noted. So let's go ahead and go to the next slide, and I will hand this off to Brenda Corona to close us out. So Brenda, the floor is yours.
Thank you. Thanks for helping me, Juan, in the beginning. So as we went today through our price formation working group, we plan to post this video recording at Expediated. As well, we plan to do timestamps within that YouTube video. So you will be able to click on the appropriate agenda item and be able to see everything that we were discussed today. And for this upcoming 2024 schedule, we anticipate having a few meetings coming up in January and February. We are mindful that these are not currently noticed, but they will be once we are able to kind of kick the ground running. But for January 10th, we do have tentatively scheduled for a working group on scarcity pricing. And then the following week will be on the 17th on the working group on scarcity pricing again. So you'll see that the 17th and 24th will be something where we are looking into either a hybrid meeting from one of those, and also keep in mind the timing might be a little bit about 3 hours. So we might adjust accordingly, but we like anyone's feedback on that. February 2024, we will kick things off with the BA level NPM, and on the 12th, and then the following 2 weeks after that will be the 26th for the working group fast start pricing scope review prioritization. So we will make sure we let everyone know on these anticipated dates with a notice, as well with that meeting that we have first coming on the 10th. But we appreciate everyone in participation for this upcoming working group. I sent those meeting attendance of who was here on the call. We sent out a few links out there to kind of look at the workshops back in March 20th and also June 26th as referenced by James. And I do see a quick question. We will get to that pretty soon. And I will go ahead and go to the next slide. I think we're wrapping things up, but go ahead, Juan. I think you might be able to want to ask that question first.
Yeah, no, I just wanted to respond to Kyle. We are definitely, we're looking at the 3 subsequent sessions. It's really to make sure that we return to scarcity pricing and kind of move that ball forward. We do understand, I think it's been mentioned a couple of times here, multitasking out of the need for survival here. So we would not have these be 3-day-long meetings or potentially even 3-hour meetings. This is more of, we're calling internally kind of a sprint. This is meant to address a couple of issues, have that inform the next discussion, and so on, to pick scarcity pricing back up and make sure we have momentum there. So we will be mindful of the other meetings that exist. We appreciate everybody's time, and so Kyle agreed entirely as far as hybrid, coordination with other work group meetings and making sure that you guys get a ROI on your time for in-person is something that we'll be very mindful of. So that's all I wanted to add, Brenda. I'll give back.
Great. Thank you so much, Juan. And we wanted to announce that we just posted a blog on the 27th of last month for enhancing resource adequacy. We do have our very own Partha, our principal for resource adequacy and market policy development, provide a lot of information during that article. Feel free to review that. I know we do have the RA working groups kicking off, so those are also kind of referencing a little bit of what we're doing. But at this time, we appreciate everyone who is able to look at that blog monthly basis. We add as much as we can relevant to what we're doing today. On the next slide, we will just kind of wrap things up for today. We are excited to share on the next slide, the January 10th. So we are very informed that we have all these kind of platforms. We are staying connected with everyone here today. We encourage you to visit the NHTSA website, the YouTube channel. We'll have those timestamps integrated, and we appreciate those who are pre-registering ahead of time for this meeting. We do have the upcoming market performance and planning forum this Thursday at 11 a.m. It's a little bit different. We want to be courteous of the conflict with the board meetings, but at this time, that meeting will be a little long, so it'll be from 11 to noon and then from 1 to 4. So we'll make sure that one's also expedited and recorded for those who are wanting to listen in for that market performance planning forum. But yeah, that agenda is already posted. Feel free to visit that. We do have some great topics that Guillermo and his team and other short-term forecasting team will also be providing. So we're very excited to share that with you today. But other than that, thanks so much, everyone. I'll give you guys a few minutes back to your time and keep going at it. We can do this. It's a little bit, but we got this. Thank you so much. Turn it back to my event producer to close. Thanks.